In this section, we will divide a polynomial by another polynomial, okay? And we also have a remainder and a factor theorem. So in this section, we will learn how to divide a polynomial by another polynomial, okay? So here, so we have a polynomial p of x, and we are dividing our polynomial p of x by another non-zero polynomial d of x, okay? And when we divide our polynomial p of x by d of x, then we can write our polynomial p of x as a d of x times q of x. This q of x is the quotient, okay, plus the remainder of that division, or p of x divided by d of x is quotient plus remainder divided by the divisor. So just let me just take a very simple example. For example, let's take a number, okay? So let's say we are dividing 35 by 6. So how do we divide 35 by 6? So what will be the quotient and what will be the remainder here? So it's 35, 6 times 5 is 30, right? So we divide, so 6 times 5, that is 30, and we subtract, and our this 5, so what do we call this 5? That is the remainder, okay? So we use r of x, and this is the quotient, which is q of x. This 6 is the divisor, we use d of x, and this number in our case it will be a polynomial p of x, okay? So here we have a p of x, which is 35. So we have a number, okay? And we divide this 35 by 6. So this 6 is a divisor, and we use d of x to represent our divisor, okay? And when we divide 35 by 6, we get a quotient 5, which is q of x, and the remainder we get 5, which is r of x. Now we can rewrite 35 as, now 35 is quotient, which is 5, times divisor 6 plus remainder, which is 5. Is it true or false? So we have our 35, okay? So 35 is equals to 5 is our quotient, so quotient times divisor plus the remainder. So 5 times 6 is 30, 30 plus 5 is 35, okay? So in general, our p of x, okay, p of x is the any polynomial, and we can rewrite this polynomial p of x as a quotient q of x times divisor d of x plus the remainder r of x, okay? So when we divide any polynomial by another polynomial or a number, we can always rewrite our p of x, or the another way is that we can also rewrite our 35, okay? So we have p of x equals to q of x times d of x plus r of x. So, and this division, it helps us to rewrite or factorize our polynomial, okay? Okay, so next here, the factors and the remainder. So we have a polynomial p of x, okay? And we divide p of x by a divisor d of x, okay? With a quotient q of x and a remainder r of x, as I said earlier. So if the remainder r of x is 0, okay, if the remainder is 0, then d of x and q of x are both factor of polynomial p of x, okay? So here so let's take example. For example, so let's divide 36 by 6. So 6 times 6 is 36. So what is the remainder in this case? remainder is 0, right? So if the remainder r of x 0, then our divisor, this 6 and the quotient 6 are the factor for our 36. Okay, so let me take a different number. For example, let me take like 35, and let's divide 35 by 7. So let's divide 35 by 7. So if we divide 35 by 7, then our quotient is 5, and we get our remainder as a 0. So whenever our remainder is 0, then the divisor and the quotient, both of these are a factor of 35. Okay, so in general we have our p of x. Okay, so in this section we will be dealing with a polynomial function. So the polynomial function will have a d of x and a q of x as a factor when the remainder is equals to 0. Okay, now here we have a specific example. So we have to find the quotient and remainder when 2x to the power 4 plus 7x cubed plus 4x squared minus 7x minus 6 is divided by 2x plus 3. So here we have this polynomial. So let's call this polynomial p of x, and we are dividing this polynomial p of x by 2x plus 3. So how do we represent 2x plus 3? This is our divisor d of x. Our target is finding quotient, so we represent q of x for the quotient and finding the remainder, which is r of x. So we have a polynomial p of x. Okay, so let me write down that p of x is, our p of x is 2x to the power 4 plus 7x cubed plus 4x squared minus 7x minus 6. So this is the polynomial, and we are dividing this polynomial by our 2x plus 3, which is divisor. So divisor is 2x plus 3. And in this example, we will use long division. Okay, so it doesn't mention any method, but we will use long division. Okay, and there is another method, synthetic division. So on your exam, you will be asked to use long division and synthetic division. Okay, so for long division, the very first step is that we will rewrite our polynomial in the descending order of exponent of the variable. Now we have our p of x. Now is p of x is in the descending order of exponent of the variable? So exponent of the variable, let's find. So we have x to the power, so here 4, the exponent is 3, exponent is 2, exponent is 1, exponent is 0. So 4, 3, 2, 1, 0. It's in the descending order, right? So no need to rearrange. So whenever you have your polynomial, make sure you rewrite your polynomial in the descending order of exponent of the variable. Okay, that's the first step. Now let's divide that polynomial. So let me write down that polynomial. So 2x to the power 4 plus 7x cubed plus 4x squared minus 7x minus 6, and we are dividing this polynomial by our divisor 2x plus 3. And divisor, it also has to be in the descending order of exponent of the variable. So this variable has exponent 1, this constant has a 0, right? So 1, 0 is in the descending order. So make sure to have your polynomial, the divisor, in the descending order of exponent of the variable. And we are using long division for this example. Okay, now the very first step here is that we take the first term of the polynomial 2x to the power 4. Okay, so we take the very first term 2x to the power 4, okay, and divide this first term by the first term of the divisor. Okay, we take the first term of the polynomial and we divide this first term of the polynomial by the first term of the divisor. So we are dividing 2x to the power 4 by 2x. And how much we get? What is this? 2 divided by 2 is 1. X to the power 4 divided by x is x cubed, right? And this x cubed will be the first term of the quotient, and we write down here. So this is where we write down the quotient. So x cube is the first term of the quotient. Okay, we are taking the first term of the polynomial. Okay, you take the first term of the polynomial and divide this by the first term. Okay, only by the first term, and whatever you get after division is the first term of the quotient. Okay, any question up to here? Now the next, we multiply this quotient and every term of divisor. Now we multiply x cube and every term of divisor and write down below this polynomial. Okay, so x cube times 2x is 2x to the power 4. X cube times positive 3 is positive 3x squared. Okay, you are multiplying this quotient with every term of the divisor. Now the next here, in the long division, we have to flip the sign of these two terms. Okay, so 2x to the power 4 is positive, we make it negative. Okay, 3x squared is also positive, we make it negative, and we are using this new sign. Okay, now 2x to the power 4 and negative 2x to the power 4 is 0. Okay, 7x cube minus, this is 3x cube, right? I'm sorry. So here, because x cube times 3 is 3x cube. Okay, 7x cube minus 3x cube is 4x cube, and we drop the remaining term. So we have 4x squared as it is, negative 7x as it is, negative 6 as it is. Any question up to here? We take the first term of the polynomial, divide by the first term of the divisor, we get x cube, and we multiply x cube and every term of the divisor and write down below the polynomial. Okay, we have to flip the sign of these terms. Okay, and we will use those new sign. Now we repeat the same process. The very first step, you take the first term here. Now this is our new polynomial. Okay, so this is our new polynomial. Now we take the first term, so 4x cube. Okay, you take 4x cube and divide that first term by the first term of the divisor. Okay, our divisor is 2x. First term of the divisor is 2x. Take the first term, divide by the first term of the divisor. So 4x cube divided by 2x. What is that? 4 divided by is 2. X cube divided by x is x squared. Okay, and this positive 2x squared is our next term of the quotient. So 2x squared. Now we take this 2x squared and multiply every term of the divisor and write down below this polynomial. Okay, so 2x squared times 2x is 4x cubed. 2x squared times positive 3 is positive 6x squared. Okay, next step, we flip sign. Okay, 4x cube is positive, we make it negative. 6x squared is positive, we make it negative. Positive 4x cube, negative 4x cube, 0. Okay, 4x squared minus 6x squared is minus 2x squared, and we drop the remaining term. So we have negative 7x as it is, negative 6 as it is. Any question up to here? Now we repeat the same process. Now our first term is negative 2x squared. So we take negative 2x squared. Okay, so make sure you are taking sign as well. Okay, so negative 2x squared, and we are dividing this negative 2x squared by the first term of the divisor, which is positive 2x. So negative 2 divided by negative 2, that is negative 1. X squared divided by x is x. Or simply you can write negative x. And this is our next term of our quotient. So you write down here negative x. Now you multiply negative x and every term of the divisor. So negative x times positive 2x, that is negative 2x squared. Negative x times positive 3, that is negative 3x. Now we change sign. So negative 2x squared change into positive 2x squared. Negative 3x change to positive 3x. So negative 2x squared, positive 2x squared, 0. Negative 7x, positive 3x is negative 4x. And we still have negative 6, and we drop that negative 6 as it is. Now we repeat the same process. Okay, you take the first term, negative 4x. So you take negative 4x, divide by the first term of the divisor, 2x. Negative 4x divided by positive 2x, that is negative 2. And this is your next term of the quotient. So we write down here negative 2. And we multiply negative 2 and every term of the divisor. So negative 2 times positive 2, that is negative 4x. So negative 2 times positive 2x is negative 4x. Negative 2 times positive 3 is negative 6. We change the sign. Do not forget to change sign. So negative 4x change into positive 4x. Negative 6 change to positive 6. So positive 4x, negative 4x, 0. Positive 6, negative 6, 0. So here we have 0. Now this 0 is our remainder, which is r of x. Okay, this is our quotient q of x. So our remainder is 0 and the quotient is x cubed plus 2x squared minus x minus 2. Okay, any question up to here? Now, since the remainder is 0, what can we say about our quotient q of x and the divisor d of x? Both of them are the factor of our polynomial p of x. Okay, and as mentioned in the definition, we can write our polynomial p of x. Okay, so let me write down that p of x. So we can rewrite p of x as the quotient time. So our quotient is x cubed. Quotient is x cubed plus 2x squared minus x minus 2. So our p of x is, this is our q of x time the divisor. Divisor is 2x plus 3 plus r of x, which is 0. So our polynomial p of x is, this is the quotient q of x times divisor 2x plus 3 plus remainder r of x, which is 0. Okay. Any question? Now let's use the same method for our example 2. Okay, in example 2 it does tell us to use synthetic division. Okay, we will use synthetic division as well, but before that let's practice one more long division for this polynomial. Okay, so here we are dividing our polynomial 6x cubed plus x minus 1. So we are dividing this polynomial by x plus 2. Okay, so this is still gonna be long division. Okay, so let me do here. So our polynomial p of x is 6x cubed minus, sorry, plus x minus 1, and we are dividing this polynomial by x plus 2. So this is our divisor, okay? So let's use the long division. So at first we rewrite our polynomial and the divisor in the descending order of exponent of the variable, and it's already in the order, so no need to rewrite. So our polynomial is 6x cubed plus x minus 1, and we are dividing this polynomial by our divisor x plus 2. So what is the first step? You take the first term of the polynomial 6x cubed. So let's take first terms, positive 6x cubed, and we divide this first term by the first term of the divisor. So we are dividing 6x cubed by x. And what is this equals to? So what is 6x cubed divided by x? That is 6x squared, right? And this is our first term of the quotient. We write down here 6x squared. Next step, we multiply 6x squared and every term of the divisor. So this is our divisor. We are multiplying with this 6x squared, okay? So 6x squared times x is 6x cubed. 6x squared times positive 2 is positive 12x squared. Then what is the next step? Flipping the sign, okay? So our 6x cubed is positive, we make it negative. 12x squared is positive, we make it negative. So negative 6x cubed, positive 6x cubed, it is 0. Now here, this is negative 12x squared and this is positive x. These two are not like terms, okay? So we do not simplify and we write down every remaining term. So we have negative 12x squared as it is. We drop the remaining positive x and negative 1 as it is. Any question? Now we repeat the same process. You take the first term, negative 12x squared. So we take negative 12x squared, divide it by the first term of the divisor, x. So negative 12x squared divided by x is negative 12x. And this is our next term of the quotient, which we write down here, negative 12x. Now you multiply negative 12x and every term of divisor. So negative 12x times x is negative 12x squared. Negative 12x times positive 2 is negative 24x. Stop me if you have a question, okay? The next we change sign. So this 12x squared is negative, we make it positive. 24x is negative, we make it positive. Now positive 12x squared, negative 12x squared, 0. Now we have positive 24x plus x. What is that? Positive 25x. And we drop the remaining term, negative 1, as it is. Now we repeat the same here. You take the first term, you take 25x and divide by this first term, x. 25x divided by x is 25. And this is your next term of the quotient which we write down here. Now the next, you multiply 25 and every term of the divisor. So 25 times x, that is 25x. 25 times positive 2, that is 50. Then next you change sign. So 25x is positive, make it negative. 50 is positive, make it negative. So negative 25x, positive 25x, 0. Negative 50, negative 1 is negative 51, negative 51. And this is our r of x. So this is our remainder r of x. This is our quotient q of x. Okay, and we can write our p of x. So let's rewrite our p of x. So p of x is quotient times, so let's write down quotient, which is 6x squared negative 12x positive 25 times divisor, which is x plus 2 plus remainder, which is negative 51. So this is our quotient q of x. Okay, this is our divisor d of x, and this is our remainder r of x. Okay, so every time we can rewrite our p of x as a q of x times d of x plus r of x. Okay, any question for long division? So there will be one question where you will be asked to divide a polynomial by another polynomial using a long division. Now, since the remainder is not 0, so our remainder is negative 5. Now, are these two a factor of our polynomial? Now, is divisor x plus 2 a factor for p of x? No. Okay, to be a factor, remainder has to be 0. In our very first example, so here when we divide our given polynomial by 2x plus 3, our remainder is 0. Because of that, this quotient and this divisor are the factor. But in this example, our remainder is not 0, and because of that, this divisor and this quotient are not a factor. Okay, so this divisor is not a factor of p of x. Okay, so this is how we do a long division. Okay, now the next method, we have a synthetic division. Okay, it's the same. We are dividing our polynomial by a divisor. Okay, using a synthetic division, and we use synthetic division only in one case. Okay, if our divisor, so if our divisor d of x is in the form x minus some number a. So if your divisor d of x is in this form, now this is a linear form. Okay, the variable has a degree 1. Okay, so if your divisor is in a linear form or in this x minus a form, then only we use synthetic division. Okay, so if we are dividing by x squared plus 2, then we are not using synthetic division. Okay, so keep this in mind. So we use this synthetic division when our divisor is in x minus a form. So the first step, let me just write down our p of x. Our p of x is 6x cubed plus x minus 1. So this is our p of x, and we are dividing this p of x by our divisor. So our divisor is x plus 2. Now at first we compare this divisor with this x minus a and find the value of a. So if we compare x plus 2 with x minus a, so let's compare with x minus a. So what is our a equals to? Do you all agree it's minus 2? Right? Because we can rewrite x plus 2 as, so we can rewrite x plus 2 as a x minus minus 2. Okay, and if you compare, so for x we have x, for minus we have minus, and our a is minus 2. So we compare with x minus a and find the value of a, which is minus 2 in this case. And writing our polynomial in the descending order of exponent of the variable is always the first step. Okay, now it's already in the order, so we are not rewriting. The next step, you compare your divisor by x minus a and find the value of a, and that a is negative 2 in this case. The next step, we write down the coefficient of each term on the polynomial. Okay, now here this is our polynomial. Now we are writing the coefficient of each term on that polynomial, okay? Now the very first term is 6x cubed. What is its coefficient? 6. So we are writing 6. Now after x cubed terms in the descending order, which term comes in general? So our very first leading term is 6x cubed. Now in the descending order, which term should be there in general? We should have a square term, right? Now do we have a x square term? We do not have. And if that is the case, then we use 0 as a coefficient. So if there is any missing term, then always make sure to keep 0, okay? Our x square term is missing, and because of that we have 0 here. After x square term it comes x, and what is the coefficient of this x? What is the coefficient of x? It's 1, and at the end we have a constant -1. We are writing every coefficient, okay? We are writing the coefficient of each term, and if there is any missing term in the middle, then we use 0. Okay, so we have a x cube as a first term. So we have this cube as a first term. In the descending order, we must have a square term, x term, and a constant. But our square term is missing, and because of that, we have 0 here. Okay, and we are dividing this coefficient by our a, which is -2. Okay, so we are dividing by a, which is -2. Now the very first step of dividing is we drop first coefficient. So first coefficient is 6, we drop this 6 as it is. Okay, we drop 6 as it is. So every time you drop first coefficient as it is. Okay, now you multiply this coefficient and this -2. So 6 times -2 is -12, and write down below next coefficient. You drop first one as it is and multiply that first coefficient, dropped coefficient, with your a, which is -2. 6 times -2 is -12, and write down that below next coefficient here. Okay, now in synthetic division we are not changing sign, we simplify. 0 minus 12 is -12. Okay, so no flipping sign in synthetic division. Okay, now we repeat the same process. Now you multiply -12 and this -2. So -12 times -2 is +24. Write down below next coefficient. Now we have +1, +24. So 1 plus 24 is 25. Okay, same process. Now multiply 25 and -2, which is -50. So -50. Do not flip sign. Okay, -1, -50, that is -51. And this last number is our remainder r of x. And isn't that what we had when we use a long division? We had a -51 as a remainder, right? Now, okay, any question up to here? Now our target is finding the quotient. Now let's find the quotient q of x. To find the quotient q of x, we have to know what is the degree of polynomial. Now can you tell me what is the degree for this polynomial? 3. Okay, our quotient will have a degree less than that, less than degree of polynomial by 1. Okay, so the degree of this polynomial is 3. Now the degree of quotient will be less by 1. It means 2 will be the degree of our quotient. Now if the quotient has a degree 2, what will be your first term? So how our first term should look like? If the degree is 2, then we must have a x squared, right, as a leading term. So this 6 is the coefficient of x square. Okay, then we write down this will be the coefficient of x and this will be our constant. So the quotient is 6x square, 6x square, negative 12x, positive 25. So this is our Q of x. You find the degree of polynomial, okay, and once you have that, the degree of quotient will be less by 1. So 3 is the degree of polynomial, okay. So this polynomial has a degree 3, so our quotient must have a degree 2. And to have a degree 2, our first term has to be x square, okay. And this number will be the coefficient of x square, and you just write down in the descending order. After x square, you write down x, and after x, in the descending order, it comes a constant, right? So there is no variable. So 6x square, negative 12x, positive 25 is our Q of x. And that's what we had here using our long division. See, it's the same quotient. Okay, and this is how we can use our synthetic division to divide our polynomial. Now let's go back to our first example and use synthetic division. Okay, now here let me make it easier. Okay, so let me use that polynomial. Okay, so I need to find a space here. So our polynomial is given as the very first polynomial. I will take the first polynomial. Okay, we have p of x as 2x to the power 4 plus 7x cubed plus 4x square minus 7x minus 6. So this is the first polynomial, and let me change the divisor. Let's say we are dividing this polynomial by x minus 1, let's say, okay, using synthetic division. Now what is our first step? We rewrite our polynomial in the descending order of exponent of the variable, which is already in the order, so no need to rewrite. Second step, we compare our divisor d of x with x minus a. From this comparison, we have to find the value of a. So what is the value of a? Our a is equals to 1, right? Because for x we have x, for negative we have negative, and for a we have positive 1. So our a is positive 1. Now you can also generalize. Okay, so for example, if your divisor has a positive, then your a is negative. Okay, and if your divisor has a negative, then your a is positive. Okay, the next step, we write down the coefficient of each term. So let's start with this 2x to the power 4. What is its coefficient? 2. In the descending order, after x to the power 4, we must have x cubed. So we have x cubed, its coefficient is 7. Then the next is square term, which coefficient is 4. Next is x, whose coefficient is negative 7. And at the end, we have negative 6 as a constant. So we write down coefficient of each term. Now, in case if there was no 7x, what difference we see here? So instead of negative 7, we will have 0. Okay, in the similar way, if 7x cube was missing, so instead of this 7, you must have a 0. Okay, so if there is any missing term in the middle of polynomial, then make sure to have a 0 as the coefficient. And we are dividing this coefficient by our a, which is 1. So what is the first step? We drop our first coefficient as it is. So you drop 2 as it is. Next, you multiply 2 and 1. Write down below next coefficient. So 2 times 1 is 2. Write down next coefficient. Now you are not changing sign, you are simplifying. If you are if there is positive, you are adding. If there is negative, you are subtracting. 7 plus 2 is 9. Multiply with 1. 9 times 1 is 9. Write down below next coefficient. Positive 4 plus 9, positive 13. 13 times 1 is 13. 13 minus 7 is 6. 6 times 1 is positive 6. This is 0. Now what is this 0? This 0 is our remainder r of x. Now the next we have to write down the q of x. Okay, so next our target is we need to know what is q of x. Now before that you need to know what is the degree of polynomial. So what is the degree of polynomial? 4. Now the degree of quotient will be 3. Okay, it will be less by 1. And to have a degree 3, what should be our first term? It should be x cubed terms. Okay, so this is our x cubed term. This will be our x squared term. This will be our x term, and this is our constant. Okay, so 2x cubed is the first term. So 2x cubed. Okay, you are writing this together. Now this is positive 9x squared, positive 13x, and positive 6. This is a constant, and this is our quotient. Now in this case, is our divisor x minus 1 a factor for this polynomial p of x? It is a factor, right? Because we have remainder equals to 0. Okay, any question up to here? So long division, so there will be one question where you have to use a long division. There will be one question where you will be using synthetic division. Okay, so make sure you know these two. Okay, now the next here, we still have a more synthetic division here. So if we are dividing our p of x by x minus c, okay, I use a here, okay, but it's okay. So if we have a polynomial p of x and we are dividing that p of x by our x minus some number, okay, c is any number, then the remainder r of x is p of c. Now what does it mean? So here we have example. So our p of x is given as, let me write down that, negative 2x to the power 4 plus 6x cubed plus 3x minus 1. So this is our p of x. Okay, and here it's asking us to find p of 2. And how do we find p of 2? We replace every x by 2. Okay, so instead of x we have 2 here, so we replace every x of this polynomial function by 2. So this is negative 2 times 2 to the power 4 plus 6 times 2 cubed plus 3 times 2 minus 1. So negative 2 times 2 to the power 4, that is 16, plus 6 times 2 cubed, that is 8, plus 3 times 2, 6 minus 1. So this is negative 32 plus 48 plus 6 minus 1 is 5, and this is, so negative 32 plus 48. What is that? Is it 16? 16 plus 5, 21. And this 21 is the remainder r of x. Okay, when we divide this p of x, okay, when we divide our p of x by x minus c, our c is 2 here, x minus 2. So when we divide this polynomial by x minus 2, then our remainder is 21. Okay, so okay, any question on this one? And let me do very similar example. Let me do one more example based on this remainder theorem. Okay, now let me take the previous case. So we had our polynomial p of x, 6x cubed my positive x minus 1, and we are dividing this d of x by x plus 2. Now here, and our target is finding r of x. Now how would you find r of x? So what option do you have? So we have this 6x cubed plus x minus 1 as a polynomial, and you are dividing this polynomial by x plus 2. Now if you are asked to find the remainder, so what method will you use here? So we can use a long division, right? So we did use a long division. We had a 51. We can use a synthetic division. We have also negative 51. Now instead of that, if you are simply asked to find a remainder, and if your divisor is x minus c form, okay, if your divisor in x minus c form, okay, so our divisor is x minus c form, both of them are in linear. So for x we have x, for c what do we have? What is the value of c? C will be negative 2. So if your divisor is in x minus c form, to find the remainder, you replace every x of the polynomial by this c. Okay, so it means you find p of c, which is p of minus 2. So let's find p of minus 2, which is 6 times minus 2 cube plus minus 2 minus 1. So 6 times minus 2 cube is minus 8, positive minus 2 minus 1, negative 48 minus 2 minus 1, negative 51. And this negative 51 is the r of x. Okay, so even without using long division and a synthetic division, we can find our r of x. And this is the remainder theorem. Okay, this is according to our remainder theorem. But there is one condition. We use this method when our divisor is in x minus c form. Only in one case you can use this remainder theorem. Okay, so instead, if you are okay, now here instead of x plus 2, if your divisor is x square plus 2, you are not using this theorem. You have to use, which method we have to use? It has to be long division, not even a synthetic division. You only have one method to find the remainder. Okay, so this is about our remainder theorem.